the quiz now. So let's. All right. So having a look at the quiz, we've got this first one. We need to find which of these is going to be the inverse function. So there's two things we need to do. We need to find out what the domain of the inverse function is, and we need to find the expression for the inverse function. So let's start with the expression. We've got x is equal to root 2 sine y over 2. And that's going to give us, if we rearrange it, we are going to get y is equal to 2 arc sine of x over root 2. That's the inverse function. We need to find also, if we look here, we're told what the domain of the original function is. So use these values to find what the range of the original function was. So there's the original function. We want to find f of minus pi over 2, which is going to give us root 2 times sine of minus pi over 2. So the sine of minus pi over 2 is going to be minus 1. So this gives us root 2 times negative 1. And if we want to find f of pi over 2, we are going to get root 2 comma 1. That's going to give us minus root 2. This is going to give us root 2. So this is the domain, this is the function, the range of the original function. It'll also be the domain of the inverse function. So we just need one that matches this. So this here matches there. Wait. Sorry, I see my mistake there. I'm missing this. I'm missing that 2 there when I'm putting it in the function. So I've made a slight error here. All right. So that is going to give us, because we've got a divide by 2 there, that's going to give us minus pi over 4, which is going to give us root 2 times negative 1 over root 2, which is going to equal minus 1. And then for the other one, we're going to get root 2 multiplied by 1 over root 2, which is going to give us 1. So it should be C. Yeah, that one's going to match as well. And that matches there. Okay, so C. Let's have a look. Next one. Ooh, the graph of the function. All right, so there's a bit of repetition there. So what we need to do for this one is we need to figure out what our period is. Our period in this function is going to be from here to here. There's a half period. So if this is 8, our period is equal to 16. If this is 8, our period is equal to 16, because that's half a period. So what we need to do is we need to bring this interval forward into the interval what we can see here between minus 2 and 10. So if we take negative 51 and then we add 48 to it, we'll get minus 3. We can almost see that. So I'm going to add multiples of periods. So 3 periods is equal to 48. So minus 51 plus 48 would be minus 3. Minus 43 plus 48 is going to be 5. So from about here to here. So there is the interval that we're talking about here. It's going to be represented by this. then what do we have to do? In that interval, it's not increasing, it increases and decreases. It is concave down, so D, concave down. Which of the following express the complex number? Okay, so this one looks pretty easy. We need to convert this number into polar form. So we've got -7 minus 7i. So our complex number is -7 minus 7i. This implies that the r is equal to the square root of 49 plus 49, which is equal to 7 root 2. And then we need to find the argument. So it's -7 minus 7i. So one of the important things to do on that one is to sketch where it is in the complex number plane. It's going to be down here in the third quadrant, which means our angle is obviously when the real and imaginary parts have the same magnitude, it's one of those multiples of 45 degrees or pi over 4. So this is going to be 7 pi over 4 down there. So it should be z is equal to 7 root 2 cosine of 5 pi over 4 plus I sine 5 pi over 4. Let's see if we have one that matches that. So I think D there matches that. If I expand the bracket. How are we doing for time? Good. Okay, question number 4. So in the xy plane, standard position measures 2 pi 3, so we're in the second quadrant. A circle has this radius. What are the... all right, okay. So let's do a little sketch for this as our starting point. We'll sketch it. We've got 2, so we're up here like this, and our angle is 2 pi over 3. And we need to find out the coordinates of that point. So the coordinates of the point, the radius is 1 over root 6, and then we need the cosine of 2 pi over 3. Let me just think through my exact value table. I go pi over 6, pi over 4, pi over 3. This is a half, and this is root 3 over 2. And this one's going to be a half. So then switching it across, our cosine value is going to be minus a half. Our sine value is going to be root 3 over 2. Expanding our bracket, we get minus 1 over 2 root 6, and we get root 3 over 2. And I'm going to write that as root 2 root 3 instead of root 6. It'll help me simplify. So cut those off. Now I've got a selection of things to look at here. A lot of them have a denominator which has been rationalized, so I'll just rationalize the denominator here. That would give me minus root 6 over 6 times 2, 12. This one would give me, rationalizing my denominator, I'm going to get root 2 over 4. Okay, let's hope this is one of them. Which question are we on? Question 4. Is that? I think it looks like the first one, doesn't it? Yeah. If it wasn't that one, I would probably take this, if it wasn't that one, it's not going to match the other ones, but I would probably take that one and rationalize it in order to see if it's hidden there as well. So it's best just to rationalize them all till you find the correct one. Okay. Sorry, I'm going a little bit quickly. I'm sort of doing it at exam speed today, but you can watch it through later in your own speed and pause a few times. All right. So here on this one, we've got the function g of x, which is equal to cos x, so the cosine value. And we've got our angle. We're on question 5 at this point. We've got our angle pi to theta. and theta is shown there. So let's get, there is pi, here is theta. So alpha is an angle in this period here. And we are talking about the cosine value. So the cosine value is the x coordinate here at this particular point. And we can see that the x coordinate of alpha is going to be a smaller negative number than theta's. So it's going to be A. That was pretty easy. So if we're looking at the x coordinate, it's going to be somewhere between, let's say, minus 0.8 and minus 1. So it's smaller than the g of theta is smaller than g of alpha is smaller than g of theta. No, minus 1 is less than minus a half. Okay, so G is given as, ooh, this is fun. All right, what's the period? So this is a tangent function. The period of a tangent function is pi divided by b. So that is pi divided by, and b is simply pi over 3, which is going to equal 3. A. Hope you got that one right. 7. We got another function. Okay, so we want to start off with this one by solving the equation. So this one is an equation to solve. We've got 4 cosine squared x minus 1 is equal to 0. So cosine squared x is equal to 1 over 4. Cosine x is equal to plus minus 1 over 2. So where is the cosine equal to a half? Let's pop up our unit circle. Cosine is equal to a half in the exact value table when we get to pi over 3. So our first solution is going to be here at pi over 3. But that also is minus pi over 3, which is down there. And this is the value x is equal to a half. We have a second set of solutions over here at 2 pi over 3. And this is, this is where x is equal to minus a half. So and then we're solving the equation. It's not given in the equation that we're solving any particular interval. So we are going to be, I think it's looking like C, isn't it? Yeah. So just solving our equation, we've got x is equal to plus minus pi over 3 plus n 2 pi, and x is equal to plus minus 2 pi over 3 plus n 2 pi. This one is from, the first one is from x equals a half, cos x equals a half. The other is minus a half. Now, the thing is that pi over 3 plus pi is that one. And 2 pi over 3 plus pi is this one. So it's going to be C. What are we on now? 4 minutes. Question 8. Ooh, this one is hard. This is the hardest question. So we've got the equation 0 is equal to 3 plus 5 tan x. That means that tan x is equal to minus 3 over 5. Now, arctan of x, let me do a unit circle. Arctan of minus 3 over 5 is there in the fourth quadrant. The tangent of that one, so this was where we would find arctan of 3 over 5. This is where we would find arctan of minus 3 over 5. So if we look at the interval specified here, we need to be in this interval here. Now the arctan of minus 3 over 5 is not in that interval. It is in the interval from minus pi over 2 to pi over 2. We have to rotate this value around by adding 2 pi. So we could add 2 pi to this, but we don't. So these ones are in the wrong interval. So we mark those in red. These are in the wrong interval. This one would need to be 2 pi plus this value. But this rotation here, subtracted from there, will bring us to the right place. So 2 pi minus that rotation will bring us to the right place. It's going to be D. Question number 9. Which of the following is equivalent to the expression? So you want to expand this using the double angle. Let's have a look.
Your kids took a test and now you're teaching afterwards?
I'm solving the test for them. All right, we're going to run out of time there on this video.
Slave driver over here.
Let me give you the answers here for this one. So this one is going to be not C, it's going to be B. This one's going to be C.
Can't you just show them the answers when you unlock the test? No?